Okay, I thought I had a problem in that last lecture, but it was seeming to work, but I had to split in two. So sorry about that. I want to show you a picture of Alpha Centauri, a picture of the Alpha Centauri star system. Now, it's kind of hard to pick it out in this picture, but let me just talk about some things here and then I'll show it to you. First of all, right in the middle here, this is a view of the southern hemisphere sky, a view that we can't get from Santa Rosa or Northern California. You'd have to go farther south, I mean, probably past San Diego into Mexico to see this region. And if you get farther, really farther south, I mean, get into South America, and you go to Australia, you'd see this area. Well, take a look here. Here is a cross. Look, the staff of a cross, the crossbar. Guess what you'd call a cross seen in the southern hemisphere? It's the Southern Cross. It is the Southern Cross. Now, we haven't gotten to Alpha Centauri yet, but I just want to show you this first. Look at the Southern Cross. Look at the stars. Notice that these three are kind of bluish, and that one's kind of orangish, yellowish. Why? Temperature. We had talked about that. A bluer star is it hotter or cooler? It's hotter. And an orange star is cooler. Now, these may not just be individual stars. It could be multiple stars, and the combined light is bluish light here, and the combined light is orange light here. I'm not even sure for these stars, but this is the Southern Cross or crux. Now, look over here. This region is the constellation of the Centaur, half person, half horse. And the brightest star in the Centaur is the Alpha star, and it's right there. That is Alpha Centauri. That is that triple star system we had put down. How come it doesn't look like three stars? It looks like just one blob of light. Well, we're so far away from it. Even though it's the closest star system to us, it's still so far that you're not going to be able to distinguish individual stars with your naked eye. Even with telescopes, you can't. The stars are so far away. Even the closer ones are not close. We'll talk about that. We can't even comprehend how far away these stars are. Oh, sorry about that. I mean, humans cannot do it. Humans just cannot visualize, be able to have this conception of these distances. Well, there's Alpha Centauri. It's the three-star system. And the combined light, because the two of the stars, one of the stars is yellowish, one of the stars is orangish, and one of the stars is reddish. Of those three stars, Proxima Centauri is reddish. So that's the combined light. Now, here's something kind of interesting. Look at that. That's the second brightest star in Centaurus. Guess what it's called? Beta Centauri. Beta Centauri. Well, that's not one star, it's three stars. And those three stars are 100 times farther away than the Alpha Centauri system. Well, that's crazy. If it's 100 times farther away, shouldn't it be way fainter than it looks? Well, yeah, except that some of the three stars there, I think at least two of them. What can you tell about the color of that? Doesn't it kind of look bluish? These are more massive stars, very massive, at least a couple of them, bluer stars. So they're much brighter. And that's why something 100 times farther away than that can almost look as bright. And you can tell he's blue. You can't tell the distances of stars by looking at them. There's really only one thing you can tell. I mean, you can kind of get an idea of distance a little bit. If something is orangish or red and it looks pretty bright, well, it's got to be pretty close because those stars aren't that bright. If something is bluish, I mean, and it looks faint, it's got to be really far because the bluer ones, and it could be the combined light from multiple stars. Yeah, you can get a little bit of an idea of distance, but in reality, just looking up there, everything looks the same distance. It's really, really hard to tell. You can only tell one's brighter than the other or another, but it's hard to tell distance. And so there might be different reasons they're brighter. One could be closer, one could actually be hotter. I mean, there are other reasons. So multiple star systems, but I think it's a pretty really neat view of what's out there. And there's other things you can see out here besides the Alpha Centauri star system. Look at these reddish areas and dark areas. There are these clouds of gas and even clouds of dust called nebulae. Nebula is just Latin for cloud. Well, this reddish region is a place where stars are being born. And it's called an emission nebula. Here are places where there's dust, like iron dust and carbon dust blocking your view. So there's so much out there. If you take a picture, you can really get the colors. With your eyes, you can't see the colors. Just like being in full moonlight, walking out in the full moonlight, you may be able to see Oh, sorry about that. Cat is my cat, very noisy unless I pick him up. But other than if I don't pick him up and he's around me, he's going to be barking up a storm. So I pick him up, and now he's on me, and it's kind of, well, yeah, it's harder to do things, but he's content, so that's good, and then I'm content. All right, so now I even forget what I was saying. Yeah. Oh, if you go out in full moonlight, you're going to see the ground. You're going to be able to walk around, but do you see colors? No, everything kind of looks like a grayish color, like a brighter gray or darker gray, kind of like even a black color. But if you were to take a picture in full moonlight, just for like a few seconds with a camera, have the shutter stay open, you'd see the colors. You'd see the colors of the trees. You'd see the color of the sky being blue. Yeah, you take a picture of full moonlight of the sky, probably 5 seconds or something. You have a blue sky. You can't see that with your eyes, but you can with moonlight is just reflected sunlight. So when the sun light gets scattered off of nitrogen in our atmosphere, nitrogen gas scatters blue light. So if you have moonlight, you're gonna have a blue sky, but it's not bright enough for you to see unless you take a picture. So yeah, with these, look at this nice picture. You might say, oh, that's fake picture. All these fake colors of stars of that. No, this is a real picture. You just can't see it with your eyes. But if you take a picture like we do in Astronomy 12, if you ever get a chance to take an Astronomy 12 lab, if not, I would actually wait to take it, because who knows when we're going to get to go out again, and maybe hopefully soon. You get to take pictures like this, not of Alpha Centauri in the Southern Cross. We don't have those in our sky, but you get pictures of nebulae, of dark nebulae here, and emission nebulae, and the colors of the stars. Just beautiful. And cameras can pick up what your eye can't in this aspect. We just talked about emission nebula. Look what's out there. We have these emission nebula, places where stars are being born. There are baby stars in here. It's hydrogen gas emitting light because the stars are exciting or energizing the gas. And this is the Orion Nebula in the wintertime. You can go out with binoculars and see this. If you go out during the winter time, you're not going to see the color. It'll look kind of grayish, but when you take a picture, you get the real color. And if you take a picture through a telescope, you zoom in and get the color, and can maybe even see the baby stars. Look at that dark. This is just a beautiful shot. You may say, it's Photoshop. It's someone drew this. No, it's the way it looked. The way it looks. Oh, look at that. Another picture of the Orion Nebula, even closer. Look at that red there. When you see red of these emission nebulas, reddish, it means hydrogen. It's hydrogen gas. It glows red when heated by stars around it. When stars die, we're talking about the stars out there, they'll give off their outer shells if it's a lower mass star. You got a planetary nebula. When a higher mass star dies, it blows up. This is the Crab Nebula. We'll talk about this. This is exciting. This is something that was seen in 1054, on the 4th of July, of all dates. Chinese astronomers reported a guest star. It was so bright you could read by it during night, and when the sun was up, you could still see it in the blue sky. So this is the Crab Nebula. We'll talk about that. Now, look at this view. Do you notice something here that this band of light? Let's talk about this. Let's talk about what that is. So we're going to stop share here. What we have to do to talk about that, what we have to do is go back to our picture here and take a look at, there's the solar system, remember? Here's the Alpha Centauri star system. And remember our thumb? Yeah, don't forget your thumb. Remember what happens if it's close? It looks big. But what happens if you move it farther away? It looks smaller. Well, what we're going to do is we're going to move far away from the solar system and Alpha Centauri system. And the solar system, I'm going to make them a different color here so you can see it a little better. Here's the solar system right there. I'm going to move it over a little bit. Here's the solar system right there. Here's the Alpha Centauri system. Look, remember we showed them like a distance apart? We're so far away now that there's the Alpha Centauri system. How come they look so close together? They're really not. And we'll talk about distances like later in a little bit, but not now. How come they look so close? They look so close together when they're not. Because we're far away. If two things are far away from you, and they're kind of like pretty close to each other, pretty close relatively, they're going to look like one thing if you get far enough away. Well, we're pretending we're far away. Now let me show. That's two star systems, right? Solar system, Alpha Centauri. Look at this. I can show the Beta Centauri right there. This would be 3 stars. Every time I make a speck, it could be multiple stars. Now look, I'm going to do this. I'm showing star systems. I'm going to have to speed this up too. I'm doing about 3 a second here. Star systems. A lot of them. See this? Hope you're taking notes. Star systems. And it's not just over here. Look, over here. And here. Star systems. I'm doing about 3 a second. I got to speed this up. We don't have all day for this. Yeah. And there's actually a lot of them right here. And is he over here? Got to really speed this up. Hope you're taking notes. Remember I said I could test you on what I write. So make sure you're taking notes on this. Now, we've already been doing this for like, I don't know, like a minute. Seems longer. And if I were going to do this and make it accurate, the star systems, I'm doing 3 a second. I'm trying to do 3 a second just so it doesn't take all day. Well, actually, I shouldn't have been talking about all day, because do you know what? If I were to do this accurately at 3 a second, it would take over 7,000 years. So I'm just going to do a few more. I don't really plan on finishing. Okay, that's good enough. All right. Okay. I'm going to kind of like circle, or well, not really circle. I'm going to kind of outline this thing, what it would be like had I finished. Kind of making it not quite as thin as it should be. Look at that. Now that looks weird. This, I mean, some people say, what is that thing? And some people say it looks like 2 sunny side up eggs back to back. Okay. 2 sunny side up eggs back to back. And so now, okay, could look like that. Some people have said it looks like a wristwatch opened up. Looked like an opened up wristwatch. Yeah, it kind of looks like that. Some people have once said it looks like the saucer section of the Enterprise. You know the saucer section. Look, I kind of can show you this. Look, I can kind of line it up. Look at that, the saucer section of the Enterprise. And then when someone said that at one point, someone said, "What's the Enterprise?" And then the person said, "It's the spaceship from Star Trek." Then the person said, "What's Star Trek?" And then the conversation was over. I mean, people know Star Trek today, right? I mean, people watch the movies, the newer movies. I mean, a while ago when they're just the episodes on TV, and maybe people didn't know Star Trek, but everybody know, right? Chris Pine, right? You know, Zoe Saldana? No? All right, yeah, some of those Star Trek. I love Star Trek, the original with Kirk and Spock. I mean, I grew up as a baby watching that. Okay, I'll stop talking. You guys, you may not be still hanging with me, but all right. So what is this? It's not 2 sunny side up eggs back to back. It's not a wristwatch. It's not the saucer section of the Enterprise. What is it? It's a galaxy. It's a galaxy. I'm going to star that. You should know what a galaxy is. And if you don't yet, we're going to talk about it. A galaxy is a grouping of what? What are these? What are all these specks I made? Star systems. A grouping of billions of star systems. What holds them together? Their mutual gravities, gravitationally bound. This is a galaxy. The galaxy is enormous. just to give you an idea of how big a galaxy is. I'm going to try to help, even though it's hard for, well, with distances like this, really humans have a tough time comprehending this. I mean, of course, yeah, I can't comprehend this stuff. Well, if the solar system, which is big enough, is the size of a dime, you know how big a dime is. If the solar system were shrunk down to the size of a dime, I just mentioned this galaxy called the Milky Way. This is what the name of our galaxy. This is ours. The Milky Way galaxy, if the solar system is the size of a dime, the Milky Way galaxy would be the size of the United States. How big is a dime compared to the United States? A dime is nothing compared to the United States. A star system is nothing compared to a galaxy. Star systems are big, but they're nothing compared to how big a galaxy is. Galaxies are crazy. I mean, we can't even visualize the size of the solar system. I mean, we can't. And I'm going to show you a video that these few guys did really well, just the size of the solar system. I'm going to post this video, really neat video that they did. A galaxy's crazy. So the Milky Way galaxy is our galaxy. And in the Milky Way, there are anywhere from 200 to 400 billion star systems. 200 to 400 billion. Now that means 200 billion, not 200, the number 200 to 400 billion. That's a big range. No, it's not just 200 stars. It's 200 billion to 400 billion. But if you write it like that, if I write it like that, I'm sure you kind of knew that. But just to be clear, so galaxies are crazy in size, and they're groupings of star systems. And if you wanted to count one per second, if you wanted to count if you wanted to count one per second for the Milky Way, it would take. Excuse me, I have to yell at my cat. Marquise, enough. Okay, all right. Sorry, I don't want to stop the lecture here, but I had to put him off my lap, and then he's going to keep barking like this. And I mean, you hear this? I mean, listen to this. Please, you done? All right. It's coming. That's good. Sorry. I am sorry. Okay. Thanks for bearing with me here. If I'm loud, I mean, you know how loud I am. He's just if he hears me, he just has to be loud too. He tries to beat me, and he's yeah. Well, okay. So now, so galaxy is enormous. So that's the galaxy. Now, if you go out and look at the galaxy, now let me share screen here. Try not to mess this up again like I did before. Well, share screen. I think this. All right, I think I'm sharing. Yeah. Now, our galaxy doesn't look like the way I've just drawn it. Our galaxy is this big flat, like pancake looking thing. Why does it look like this band of light? Why does it look like, I mean, if you look at the Milky Way, it looks kind of dense here, or like milky. The ancients actually thought it looked like a river of milk. That's why they called it the Milky Way. If you have never seen the Milky Way, go out to Lake Sonoma or Sugarloaf or something, or just, I mean, this time, go out somewhere like now. I mean, you can still, well, I guess we could still get out a little bit and go out into a dark sky and go somewhere, of course, go somewhere safe. Don't go somewhere where it's not safe, and maybe, take a friend with you. It's better to do that rather than, be out there by yourself. So go out and look at the Milky Way, this band of light across the sky. Now, what is this thing? What is it? What are we seeing right here? What are we seeing? And I want to show you that. So let's go back to this. Now, the galaxy, I showed it like this. This is an edge-on view. It's an edge-on view. Like looking at a pancake along the edge. If you look at a pancake along the edge, it looks pretty flat. Now, our galaxy is pretty flat, but I want to show you what our galaxy looks like if you look at it face on, our galaxy would look like this. Let me get a better pen here. These are stars. The way when I'm showing all this light, it's stars. Now look. That's the way our galaxy, we think, we can't even get out of it, looks. It's a spiral. It's actually a barred spiral galaxy. So edge on like this. Face on like that. So imagine turning this to the side. Oh, look at this. Like you can. And guess what? It looks flat. Doesn't it look flat? So edge on is going to look flat. Face on, it doesn't. Like a frisbee, right? Like a frisbee or a pancake or a cookie. Yeah, kind of like the cookie in Bruce Almighty. Remember the cookie at the end in Bruce Almighty? Now, so okay, it's relatively flat. So why do we see a band of light? Well, here's why. Let's go back to this picture. Now, where are we in here? I lost us. Where's the solar system? Do you guys remember? Should have been taking notes. You should have marked that. Yeah, I forgot to. Sorry, it was my fault. All right, solar system. I'm just going to have to make it up. I'm going to say the solar system is right there. I'm going to make it darker. See that? We'll call that solar system right there. You are there. You ever seen those shirts or pictures that say you are here? I say, yeah, we're there. We're not necessarily to the left. I show, hey, we're to the left in the galaxy. No, there's no left, right. There's really no up or down. I didn't share. I have to, what has just happened here? Something, let me see. Let me go back. See, are we, yeah. Oh, it's kind of like what happened before. I think we're still sharing. Share screen. Share screen. No, we're not sharing. I gotta get straight what I'm doing here. I'm kind of out of it. All right. We're share screen. We're not sharing. We're watching this. Yeah, that kind of messed me up before. That's why I had to do this next one. Something just flashed off, and I didn't know it was recording. But I think we're recording. We'll find out soon enough. All right. So there is the solar system right there. Solar system. And from our point of view, now look at this. Being in the solar system, we're in the plane of the galaxy. There's no left, right. There's no up, down. I'm just showing us in a certain spot here towards the edge. We are towards the edge of the galaxy. We are towards the edge, about 2/3 from the center to the edge. We're not at the very edge, but we're about 2/3 of the way from the center to the edge. Now, what view do we have? Well, if we look out this way, you know what we see? A lot of stars. We see a lot of stars. And we see stars and dust. There's a lot of dust we see, and even gas. But the dust blocks our view after a while. We can't see beyond that. If we look out this way, a lot of stars as far as we can see. So we can only see really to here and to maybe there, if that much. But now take a look at this. If we look this way, out that way, or this way, are we looking through as dense a region of stars? Isn't it easier to look out of our galaxy if we look away from the plane? We call this the plane, the flat part of the galaxy. If we look in the plane, it's kind of like this. Look at this. Imagine being in this thing. Oh, like a galaxy. Or imagine having a big pancake or cookie. Remember we talked about the cookie in Bruce Almighty at the end? Imagine wearing that. If you're wearing a big pancake or cookie and look along the flat part, all you see is cookie or batter. But if you look kind of up or down, you're not looking through as much cookie. It's like somebody dropping you down into the ocean, maybe like 6 feet deep. And you go down 6 feet in the ocean, you open your eyes and you look all around you towards where the ocean is far. It doesn't matter where you are in the ocean. If you are down 6 feet and you look straight along the water, all you're going to see is water as far as you can see. But if you look straight up, you only see 6 feet of water, and then you can see out. Being in a cookie, it's the same way. If you're in any part of a cookie, if you look along the plane, you see a lot of cookie. If you're in a pancake, you see a lot of batter. If you are in the galaxy looking along the plane, you see a lot of stars. And at great distances, and they get so far away from your point of view, they look milky. It looks milky. But if you look out away from the plane, you're seeing out of our galaxy. And you're still seeing stars in our galaxy. The stars you see are still part of our galaxy, but at least it doesn't look as dense. It doesn't look as dense. So look at this, just to show you why that is. Share. All right, we're sharing. We are sharing. Got to remember what we're doing. We are sharing. It's good to share. And let me go back. If you're looking along here, you're looking along the plane. And if you're looking here and here, you're looking away from the plane. And everything in here is part of our galaxy. It's just you're not seeing as dense as stars if you're looking away from the plane, and they're closer stars. Here you're seeing farther stars and more gas and more dust. And everything in this picture that you see is part of our galaxy, still part of the galaxy, except for that. Huh. Okay. All right. We'll talk about that in a little bit. Here's a picture that was taken by one of our assistants, John. Some of you guys are going to have John as your assistant. Some of you have Joe. John has a great camera. I don't think I mentioned this. Because he has a good camera, because he has a great camera, he's a great photographer. You take away his camera, he wouldn't be a great photographer. To be a great photographer, I mean, of course, you have to have an eye for things. I don't know if John's going to be watching this. I don't know if John has an eye for things. He has a great camera. If you give me that camera, I'd be a great photographer. Do I have a good camera? No. Therefore, I'm a crappy photographer. I mean, of course, there's more to it. But, well, with John, I don't think there is. All right, so now, he took this picture. Good, great shot. Look, Antares in Scorpius right here is the stinger of the scorpion. Here's Sagittarius, kind of looking like a teapot. But look, here's the Milky Way. Well, all these stars are in the Milky Way. But here is the plane of our galaxy. We're looking actually in the direction of the center. You can't see all the way to the center, but the center of the galaxy is in this direction. Look, there's emission nebulae there. Look at that look at that brightness. You say, whoa, what is that brightness? Well, we're seeing more stars in that region. We're looking into the plane, and maybe there's less dust blocking our view in that direction. You look in this direction, there's dust in the way. This darkness in here are dust lanes. You can even see darkness there. Just beautiful, beautiful shot. Look at this. John took this shot. And actually, you know what? The pictures is kind of grainy. It's not that the greatest shot. This is not because of the camera. Actually, in this case, John did a good job. I got to give John credit. Also because he might be seeing this video at some point. Look at this. It looks like a Milky Way bow. And this is from Lake Sonoma. You say, whoa, look at that. Nice green stuff in the sky. Well, it's not that nice. It's lights from Santa Rosa and Healdsburg over here, Windsor. So it's not that nice. But from Lake Sonoma, you get a pretty dark sky. This is where we go with Astronomy 12, this region. And he had a wide angle lens. And the Milky Way with a very wide angle lens, it looks like a bow. Look at the dust. Can you see that blackness in there? Look, can you see the blackness? Of course, you see the brightness there. Guess what that is? Dust. That's dust, a dust lane. Now, oh, look at this shot. We did not take this shot. No, it's still from inside the galaxy. I think it was a composite we can't get out of the galaxy. We can't even get to the closest star from us, Alpha Centauri star system. Look at that beautiful dust lane. Look at the emission nebulae here. Just beautiful. I mean, you can almost imagine the brightness farther away, and this is blocking your view, the dust. That's the way it is. That's the way it is. But look, these other things right here. We got to talk about those. So we're going to stop share. And let's talk about what's around our galaxy. Our galaxy's not it. We're not the only galaxy in town. Well, maybe it's kind of probably a poor way to say it. Well, guess what? We have other galaxies. And the closest one to us, I'm going to put right here. It's actually a very small galaxy. It's colliding with us. I'm going to circle it right here. There's a galaxy. We've discovered a galaxy over here. It's actually becoming part of ours. And what I'm going to do is I'm going to get rid of this, just so we have room. I need a right, and I'm going to get rid of that. And this galaxy this is kind of interesting. This is interesting. I want to talk to you about this. We name things based on in what direction they are. And you might say, well, what, east, west, kind of north, south, that direction? No, not that direction. In space, we name things based on the constellation it's in or beyond. We have named pretty much all the stars around us, and putting them in groupings. We put them in groupings called constellations, groupings of stars, and we've named them after animals like Taurus, the bull, people like Orion the hunter. I mean, Pisces the fish, A lot of different neat names. A lot of them are Greek constellations, and a lot of them in the southern hemisphere from sailors that sailed the seas in the 1400s and 1500s. But we have like 88 constellations we make note of. Different cultures have different numbers. Well, this galaxy happens to be in the direction, from our point of view in the solar system, from the Earth, in the direction of the big dog, Canis Major. Canis Major, the big dog. Let me try to fix this galaxy. It's been bothering me. My arms are rubbing it out. Therefore, if it's in the direction of Canis Major, we call this galaxy the Canis Major Dwarf, because it's small. Look, it's small compared to the Milky Way. Canis Major Dwarf Galaxy. The reason that you should know this, can be on the test, it is the closest galaxy to the Milky Way galaxy. That's good to know. The Canis Major Dwarf Galaxy. Before we knew about the Canis Major Dwarf, we thought that there was a galaxy over here in the direction, that's still there. I mean, galaxies do move, but over just a little bit of year, 10 years, 20 years, it's not moving much from our point of view, Well, this galaxy in the direction of Sagittarius. And yeah, I don't know if you have to remember this, but that galaxy is called the Sagittarius. Sagittarius, fix that. I-U-S-S-A-G, Sagittarius Dwarf Galaxy. A dwarf because it's small. Why Sagittarius? Because we look past the stars that make up Sagittarius to see that. I mean, we can kind of still look out and we can see that. Well, I got to tell you that I don't have to tell you this, but I'm going to, probably against my better judgment. Before they called it, usually when we discover something, there's usually kind of like a pet name of it that even astronomers give before we give it a real name. Well, the name they were giving this one when they found it was Snickers. And you know why? Because it was peanuts compared to the Milky Way. I shouldn't have told you. I didn't make that up. I mean, someone else said it. And actually they were calling it Snickers. And luckily it's called the Sagittarius Dwarf now. So, okay, I'm glad. In this case, maybe it's good that it's not a synchronous class. All right, now, so there are a couple galaxies. The sailor Magellan noticed there were these clouds in the sky. And Magellan, and I think the 1400s, right? Late 1400s. He saw these things that were cloudy in the sky. And he realized, well, after a while, that hey, he thought, oh, maybe these things are not really in the sky. Maybe they're farther away because they don't seem to dissipate. They don't seem to move. Well, guess what they were? They were galaxies. They were two galaxies. And today we have names for them because Magellan kind of, not that he discovered them, but he actually logged them. He made note of them. They're called the SMC and the LMC for the small and large Magellanic clouds. But they're galaxies. They are galaxies. They didn't know what a galaxy was then. So those are kind of good to know. You should know the Sagittarius Dwarf Galaxy is a galaxy. I mean, you put the word galaxy at the end, you kind of can remember it's a galaxy. You should know that, well, the Magellanic Clouds, the small and large Magellanic Clouds, the SMC and the large Magellanic Cloud, or the Clouds of Magellan, you should know those are galaxies. But it'll be kind of obvious when I bring them up. We're going to talk about what's closer, what's farther. So there they are. Now, I'll show you these in just a minute. I'll look in a picture. I don't have the best picture. What I want to do is this. Take a look. I'm going to show the Milky Way again. We're changing scale, though. We're changing scale now. Here's the Milky Way. There it is. Milky Way Galaxy. MWG, Milky Way Galaxy. You want to see the, well, maybe you don't, Canis Major Dwarf? There it is. Canis Major Dwarf. You want to see the Sagittarius Dwarf? There it is. Sagittarius Dwarf. What about the Clouds of Magellan? I could put them here. There's LMC and SMC and LMC. Doesn't really make a difference, but there. Small Magellanic Cloud, large Magellanic Cloud, SMC, and the LMC. I'm just showing galaxies. Well, take a look at this. Here's something you might remember. I think you might know this. You might even have known that stuff. Well, remember how galaxies get their names? Well, for the most part, not the Magellanic Clouds, but usually if they're discovered like now or around this time, by the name of the constellation. From our point of view, if we look past the stars that make up Andromeda in that direction, we have a giant galaxy bigger than ours. From our point of view there, we see a galaxy in the direction of Andromeda. So you know what we're going to call it? We call it, no, that's not right. It's close. It is the Andromeda Galaxy. It is actually the farthest object you could see with your naked eye. You can it's not the farthest, it's not the closest galaxy to us, it's not the farthest. I mean, the closest one is the Canis Major Dwarf. So it's not the closest, but it's the closest large one. But I'm not gonna ask you that. But it is the farthest thing you see with your naked eye. I might ask you that. I'm gonna say, what's the farthest thing you can see with your naked eye? Andromeda Galaxy. Andromeda Galaxy. And this is beautiful. I'm going to show you some pictures of it. Actually, I'm going to show you pictures now. So we're going to share. Okay, let's do this. This is showing the Canis Major. It's not even a real picture. It's kind of like a computer enhanced picture showing the Canis Major Galaxy being torn up gravitationally by ours. Ours is represented blue, the Milky Way. The Canis Major Dwarf and the stars from it is represented in red here. There's the main mass of it, but it's being ripped apart gravitationally by our galaxy, by the gravity of our galaxy, being tidally influenced. It's being pulled apart. So a tide is a stretching force because gravity is gravitational force different on one side of a body compared to another. Well, this is not the best picture. It's not even a picture. It's showing where nearby stars are. There's the sun, Sirius, Betelgeuse. And here is where, I guess, where the Sagittarius Dwarf is. It's kind of like not the best scale. Yeah, it's not, to actually tell you the truth, it's not a very good slide. The Large Magellanic Cloud. This is a good slide because it's a real picture. It's called an irregular galaxy, no distinct shape, very small. This is the Large Magellanic Cloud. And there's the Andromeda Galaxy. The Andromeda Galaxy. This thing is maybe twice as big as ours. And you can see it with your naked eye. It is maybe 400 to, I don't know, maybe 600 billion star systems. I mean, we're not sure exactly, but all this, everything in this picture, well, not everything, all these are part of our galaxy. These are part of the Milky Way. These are like raindrops on your window as you're looking at something far in the distance. And it even has companion galaxies orbiting it. So this is the Andromeda Galaxy. There's the center, the nucleus. Look at, there's these spiral arms here. You can see mission nebulae in here. Oh, just beautiful. I remember a close-up, high resolution image, and it's on Facebook. I saw it actually some years ago, where it's just zooming in at just a small region of the Andromeda Galaxy and just seeing how many stars are just in that one region. Just incredible. Now, stop share. Let's talk about some of these other galaxies. The companions of Andromeda that we just saw. What about some other galaxies? There's a spiral actually over here. There's a spiral galaxy called M33, the pinwheel. But most of the galaxies are very small. It turns out we have about 50 galaxies, most of them relatively small. I mean, kind of like Sagittarius Dwarf and the Canis Major Dwarf. There are about 50 of these. Some of them are kind of big, well, really big. The Andromeda is the biggest. We're second biggest in this region. And it actually is a cluster of galaxies. And I'm going to circle this cluster. That's just something important to know. Yeah, kind of like this. I mean, there it is. It really is not really circled. I mean, it's just galaxies gravitationally bound. It's called a cluster of galaxies. And it's ours. We're in it. That's part of it. I mean, we're in the Milky Way, and the Milky Way is part of this. This is ours, and we have a name for it. some of you guys know this name. It's called the local group. It's our cluster of about, I think in the upper 50s now, I'll say 50, I'll just say about 50 galaxies. Might be up like 56 now or 52. It's called a local group. It's good to know that. It's our cluster of galaxies. It is our cluster of galaxies. That is a good one to write down. Well, now, is that it? Remember how big galaxies were? Galaxies are big. I mean, you can't comprehend a galaxy. No one can. Humans can't. And we're talking about a cluster of galaxies, maybe about 50 of them. Is that it? Is that everything? No. Take a look at that. See the local group right there? Take a look. Take a good look at it. Andromeda. Turn this a little bit. Sorry, bad angle. Milky Way. And imagine we get far enough away from this. Far enough away where now the local group is like that, inside that circle. This circle right here, well, kind of circle that I've drawn, poor drawing, poor circle, is that. That is the LG local group, our cluster of about 50 galaxies. Well, if that's our cluster, well, what else is out there? Well, guess what is out here? There's another cluster. No, I shouldn't even draw the galaxies in there. I'll just show, it shouldn't be circles. I mean, but this is the easiest way for me to do it. You know what each of these circles is? That's our cluster. That's our cluster right there. That's the local, kind of right there. There's a local, just not that's any special, I mean, special to us. There's a local group, our cluster. Well, guess what? There are about, oh man, this is crazy, about 300 or so clusters. How many have I drawn? Maybe 25, 30. I need to make 300. I'm not going to even try. I am just going to do this. That. And I mean, again, this should be filled. And we're not talking about 300 galaxies. We're talking about 300 clusters of galaxies. And these clusters, sometimes little clusters are called groups, but I'm going to call them clusters. Sometimes they have maybe 40 galaxies in them, but they can have thousands of galaxies in this. And there are about 300 or so here, approximately, somewhere around there. I mean, I've heard from anywhere from 100, I think I've even for 500. This happens to be a cluster of clusters of galaxies. And a cluster of clusters has a name. A super cluster. Oh, it should be one word. Super cluster of galaxies. Which is what is it? It's a cluster of clusters of galaxies. Gravity holding it together. Gravity's holding it together. And of course, we have to have a name for our supercluster. Our supercluster, well, I got to tell you the old name. The old name, which was not the great name. Wait, can you guess what it is? If our cluster is called the local group, guess what our supercluster was called? It was called, well, it still is. It still is. The local supercluster. It's ours. This is it. There's the local super. That's good to know. It's our cluster of clusters, the local supercluster. But we have a good name. Within the last 5 years, we finally have a good name. We have a good name. We have a name. Hawaiian name called Laniakea. Laniakea. So local supercluster is good to know, but so is Laniakea. Actually, that's way better. Laniakea means immeasurable heavens. I'm not going to ask you that. Might not even be right. Someone just, I think I looked that up. I think it's right. Immeasurable heavens, Laniakea is the name of our local supercluster. You know what now we need? Now we need a new name for the local group, a Hawaiian name. I mean, I don't speak Hawaiian, but I'll take any other name besides local group, but I haven't heard one yet. At least we have Laniakea. So look at that. Look at that. Now, is that it? There it is, the local supercluster. This is incredible. Maybe 300 or so, I don't know, maybe, I'll say 300 plus or so groups. Actually, not groups, clusters. I'm not gonna test you on that. I don't even know if that number's right. This is an estimate. Well, look at that thing. There it is. The Laniakea. Let me show you Laniakea. Remember our thumb. Don't forget your thumb. We're gonna move back. We're gonna move back. We're gonna show this. Let's show Laniakea, the local supercluster. Are you kidding me? You kidding me? 300 clusters are in there. I mean, it's probably, millions. Probably, hundreds of thousands of galaxies at least. Yeah, it's great. All this. Now look. Remember the green there? The green circle? That's our Laniakea. There it is. I can't show anything in that. That's Laniakea. I'll just put L. Laniakea. What do you think that is? Guess what? Another supercluster, and another, and another, and another. This is where it's going to get hard. These are superclusters, and they're actually moving away from one another. Something's expanding. We're going to talk about that. And to make this accurate, I have to draw. Now, remember what I'm drawing here. I'm not drawing galaxies. I'm not even drawing clusters of galaxies. I'm drawing clusters of clusters. Every circle is a cluster of clusters of galaxies. And I've made about, I don't know, 25 here, 30 or something, I don't know. And to make this accurate, I'll tell you, here's it's getting ridiculous. There are 1 million plus super clusters. 1 million plus, which means there are 100 billion plus galaxies. That's ridiculous. And this would be stretching. I can't. I was going to have to draw 300 over there, right? 300 clusters, and I stopped at about 30. If I have to draw 1 million or more, I'm stopping at 30 again, all right? These superclusters go out as far as we can see, and probably even beyond what we can see. Beyond what we can see. And what do we call everything? Everything we see, everything we think is there. What is that called? You know it. It's the universe. We're just going to say everything. I mean, it's more than this. I mean, we got to go out with this. It's just crazy. It's ridiculous. The universe, it's all space and time and everything within it, all galaxies and space, or just say everything we know of. And they're saying that our universe, the universe, everything, it might not be everything. We might live in a multiverse where our universe is just like one cell in a bigger entity. You know what? If you're having trouble right now, I'm right there with you. It's crazy. So let me a few more minutes here. I got to show you a couple things here. I have to show you. Well, remember the Andromeda Galaxy? Here's another galaxy, Whirlpool Galaxy. Just beautiful face-on galaxy, and there's a companion with it. Just beautiful. These spirals are just beautiful. Just know how just kind of keep it in your mind how immense these things are. Just crazy. Yeah. Look at all these emission nebula where stars are being born. All that blue you see are these massive stars. Here's another view of the Whirlpool Galaxy. Just incredible. The Sombrero Galaxy. They say there might even be 1 trillion stars in this galaxy. And look at this. Here's another view of the Sombrero. Great shot. I mean, just in dust lane, there's a spiral galaxy. And I mean, they're a galaxy. This is another galaxy seen from the Earth. I mean, looking out there with telescopes, taking pictures. But look at this. You see these things with spikes? We say, oh, wow. Is that a galaxy? No. If it has spikes on it, it's a star within our galaxy. This is a view of one star. That's 1 trillion stars. And you say, well, that's close, relatively. That's far. And you say, well, but what are these spikes? Well, if you think about it, stars are just pinpoints of light. They're so far away, not really pinpoints. Well, in a telescope, there's usually bars that hold a secondary mirror in there. And there's light that gets bent around the bars. It's called a diffraction pattern. There's well, it's diffraction. It's not necessarily a pattern. Well, it kind of is a pattern. If it has 2 bars in the telescope where the light goes by, you have these 2, like, I don't know, 2 spikes. If there were 6 bars holding in the secondary mirror, you'd see 6 of these. So it's an artificial, it's an artifact. It's an artifact of the instrument that took the picture. And it's a pinpoint if you see something like that. Well, you see something like this, there's no spikes. Well, it's because it's not a pinpoint. It's not an individual star. It's trillions of them. The Antenna Galaxy. You see Galaxy Quest? Great movie. Funny movie. Extra point. It's just for seeing it. If I give you an extra point movie, all you have to do is see it, email your assistant because you saw the movie, and it's the honor system for the 1-point movies. For the other one, just look at the list. I mean, there's a list in the syllabus for what you have to do for the 2-point movies and more points. You do a little bit of writing. But if it's a 1-point movie, honor system. Doesn't mean if you've seen it. It means you have to see it again if you've already seen it. And if you've never seen it, actually, Galaxy Quest, you got to see it. It's a great movie, funny. And these are 2 galaxies colliding. It's called the Antenna Galaxy. And look at the dust. Look at the centers, the nuclei of these galaxies. Look at that blue there. Those are very massive stars being formed in those regions. They're just beautiful. The Tadpole Galaxy. The tadpole. Looks like a tail coming from it, which is stars and, I mean, hot blue stars and gas and dust. Look in the background. Look at all these other things. Galaxies. These are all galaxies, except for that and that. Look at that. See the spikes? Therefore, what must this be? What must that be? What must that and that be? Those are stars in our galaxy, in the Milky Way. So it's hard to get a picture of another galaxy without getting a star photobombing your shot. I mean, it's not that they jump in there to just ruin your shot. I mean, it doesn't really ruin the shot. We try to avoid the stars, but you can't. There's just so many stars in our galaxy, even if you're zooming close up. I mean, zooming out, there's still some stars in the picture, but it actually makes it more amazing shot. Look, there is 1 star in our galaxy. See that thing right next to it? Well, it's not really right next to it. That's hundreds of billions of stars. That's hundreds of billions of that. You say, no way, that's more impressive. No, it's not. It's close, and that's far. That's part of our galaxy, and that's a whole other galaxy. Almost everything of all these specks are galaxies. And now I got to show you this shot. I have to show you this shot. We're going to end on this shot, but I got to tell you about it. The Hubble Space Telescope took this. It's called the Hubble Ultra Deep Field. We tried to avoid any stars, anything in our galaxy, anything in the Milky Way. We weren't successful because look at this. See that? You see that? You see that? You see that? Probably missing some too. Yeah, looks like there are like 4 stars got in the way. But everything else here, and the everything else, I'm talking about 10,000. 10,000. I mean, 10,000 galaxies in this picture. Every little tiny speck you see is hundreds of billions of star systems. And these hundreds of billions are like every little speck you see are like the sun, not called the sun, but like what the sun is, stars, hundreds of billions of times. They're not stars. These things are not stars. They're groupings. Every little speck are groupings of hundreds of billions of stars. Now, that's not what's the most amazing about this picture. I think what's most amazing about this picture is that not that there are these 10,000 galaxies in here, and not that these 10,000 galaxies each have hundreds of billions of stars, but the size of the sky, the area of the sky of this frame from this side to this side, is what you would block off if you extended your arm with a pin, holding a pin, closing one eye, and holding it up, and looking at the area of what the pinhead would block. The pinhead would block 10,000 galaxies. Now that is ridiculous. You hold a pinhead or a pin up, close one eye, and look at the very top of the pin and say, what is behind that pin that I'm blocking? What am I hiding? You're hiding 10,000 galaxies, each containing hundreds of billions of star systems. Now that is incredible. So, well, here's what I want you to think about. You remember we said that there are 1 million plus superclusters in the universe? I mean, who knows how many? That there are 100 billion plus galaxies, 100 billion. We haven't counted them. We just extrapolate. If a pinhead blocks 10,000, and you can figure out, oh, if there's 10,000 beyond that, pretty much nothing, there must be over 100 billion if you look everywhere. Well, if there are 100 billion galaxies, how many stars must there be? Remember potato chip rule, stars are smaller than galaxies, and stars make up galaxies. So you'd have to multiply 100 billion by probably at least 100 billion or so. Well, that's a ridiculous number. There's no way we can comprehend that. But here's what I want you to try to comprehend. There are more stars in the universe, and we're just talking about the universe we know now. We're not talking about any multiverse yet. There are more stars in the universe than there are grains of sand on all the beaches of the whole world, multiplied by 3 million. Wait. I mean, no. I'll say it again. There are more stars in the universe than there are grains of sand on all the beaches of the whole world, multiplied by 3 million. Now, think about this. When you pick up a handful of sand and you start, dumping it out, you might say, wow, this is ridiculous. This is enough sand. We're talking about a handful. There still might be 1 million grains there. Think about all the handfuls of sand, and not just the sand on the top layer. I mean, you dig down until you get to pretty much dirt. Well, sand, dirty sand. Sand is dirt. It doesn't matter. So you think about all of the grains. It's ridiculous. You can't even do that. I mean, I can't do that. You think about multiply by 3 million. I can't do that. Think about all the stars are out there. And think about this. The sun is one of them. One of the grains of all the sand on the earth multiplied by 3 million is the sun and the planets which go around it, the solar system, our system. Now, let me ask you, do you think we're the only ones in the universe based on that, based on sheer numbers? I say there is no possible way. There is absolutely no way we're the only life out there. How could there be just one star of all if stars are grains, how could there just be one special star of all those grains? I mean, we're discovering stars like this. We know there's stars like the sun. We're discovering planets out there just in a tiny region around the solar system. We're discovering they're Earth-like planets. It's just a matter of time before we find out there's life. Now, I don't think there's life that's come here. People say, oh, the government's hiding aliens. I don't believe any of that stuff. I mean, could it be true? I guess. But is it likely? No. Well, there are these stupid claims. There's no evidence or anything like that. But I think there's life out there. But the distances are so great, life may be so far apart, even though the universe is teeming with life. Life could be in our galaxy, but just not even know about us yet. I mean, we're going to talk about distances, and we're going to see that. So that's what I want you to think about. I want you to just think. That's your homework for the next, that's your homework for tonight and tomorrow and the next night. Think about this just for like 2 minutes. That's all. You don't have to write anything. Just think about everything out there and think about what there might be out there. And actually, this might be the hardest thing you do in the whole semester, is to actually try to comprehend all this. Don't try to do too much. If you start getting a headache, you stop. You've done enough, and that's it. So we are done. And till we meet again.